Welcome to video 2.2D part 2, Intro to Vertical Motion.
Is the compare version. Okay, so now we're going into physics. So if you don't like science, that's too bad. Here we go. So vertical motion, which is throwing or tossing or dropping an object. So you might be standing on the ground, throwing the basketball up in the air. You might be at the top of the building, simply dropping an object. You might be tossing that object downwards. You might be tossing that object upwards. But no matter which scenario you have, our planet has gravity. And whatever goes up will come back down to Earth, okay? So on planet Earth, the acceleration due to gravity is, and you should know this from science, negative 32 feet per second squared, or in metric, negative 9.8 meters per second squared. We'll come back to that later. They're going to give you these position functions. Now, the position function is the height from the ground. That'll ought to be automatic, the height from planet Earth. And the t represents the time. So, if it's in feet, then the position function they're going to give you is that the height at times t of this object is negative 16t squared plus v0t plus s0. If it's in meters, the problem, which is numbers 99 and 100, they'll give you the formula, again, the height of the object from the ground at time t in seconds. This time, instead of negative 16, which you'll notice was half of 32, 4.9 is half of 9.8. Why it's half, that gets into integration. We'll learn that much later in the course, okay? Again, plus V0t plus S0. Now, what do the V0 and the S0 stand for? The V0 is the initial velocity, which will be given to you in the problem, and the S0 is the initial position. Was the object on the ground originally? Was the object up on, on a 30-foot building? What was the height of the object when you'd started to do this experiment? Now, first of all, you'll notice that my little man is not standing up, because all they tell you is how tall the building is. They never tell you how tall the man is standing and where he's holding it at. So I've decided that all the people that are dropping and tossing these objects are paraplegics, and they have a job now. So, and their job is to drop these objects, or maybe toss it up. His wrist does work, but he is flat and horizontal. He is part of the top of the building. So he has three choices with this object, whatever that object is. He can simply let it go, he can toss it downwards, or he can toss it upwards. If he lets it go, then obviously the initial velocity is 0. It doesn't have any velocity when it leaves his hand. If he tosses it downwards, then we say that the initial velocity is negative. It's been decided that negative velocity is going downwards and positive velocity is going upwards. And therefore, if he tosses it upwards, the initial velocity will be positive. Now, the other thing you want to understand, and this is crucial, is a derivative. And this is a different way of looking at derivative. Instead of looking at the derivative as graphically as the slope of the tangent line, we're looking at the derivative as a rate of change, which basically a slope is a rate of change. It's delta y over delta x. It's the rate at which y is changing with respect to the rate at which x is changing. So dy dx, instead of looking at it as the derivative with respect to x of y, can be looked at as the rate of change, that's because it's a derivative, of y, which is in the numerator, with respect to x, which is in the denominator. ds dt would be the rate of change of the height, which is s, with respect to the t, which is the time. Well, height over time is like feet over seconds or meters over seconds, and that is the velocity, because a velocity is a rate of change of distance with respect to time. So, if you have the position function s of t, the derivative of s of t, written this way or this way, is the velocity. And again, for vertical motion, upward motion will have a positive velocity, downward motion will have a negative velocity. For horizontal motion, so for like a car traveling, a positive velocity will mean motion to the right, or if you were in a car, it would be being in drive. And on a number line, negative velocity means the object is moving to the left, or in a car, that would mean we're backing up, we're in reverse. Speed is related to velocity. Some people think they're interchangeable terms. They are not. Velocity can be positive or negative. So velocity tells you not only how fast you're going, but in which direction. Up or right if velocity is positive, down or left if velocity is negative. Speed, on the other hand, simply tells you how fast you're traveling. So speed is the absolute value of the velocity. That's a very important thing to know. Speed is always positive. Velocity can be positive or negative. So the velocity is the rate of change or the derivative of the position with respect to time. The speed is the absolute value of that.
And that's the end of video 2.2D, part 2.